Now I made a couple of videos demonstrating on how you could run a stack of hydrogen units run in series with your electrical system. So and I also drew a schematic for it, and some people didn't understand it, so I was able to find a simulator, an electric schematic wire simulator where I don't have to go to Radio Shack and actually buy the bulbs and the wire and the batteries to prove everything to you. The simulator will do a pretty good job of making my demonstration for me. So that you better understand it, here we go. Alrighty, now here's an example that supports my other video on how to run HHO units with zero resistance. Instead of hooking up circuits in parallel hookups, we're going to hook up HHO in series hookup, which I described in my other video. And now I have this simulator thanks to PHET Colorado.edu. That's PHET.COLORADO.edu. You can check it out yourself. We're using the circuit construction kit. This is a simulator that lets you play with circuits without actually having to buy parts. Now then, here's another example. The original example I was trying to point out here. We start with battery, switch, amp meter, light bulb. One battery for one light bulb. 9 amps. 2 light bulbs ran in series, each one dimmer, running half the amps. We still only have one battery. One battery right here. Now we're going to take out this piece of wire and put a second battery, doubling the voltage. And now these light bulbs are just as bright as this light bulb. We have 9 amps over here, and we have 9 amps over here. If you have one light bulb, it takes one battery to power it. If you have 2 light bulbs, it takes 2 batteries to power it. Alright? Here's another example. We have the same one bulb run by one battery, drawing 0.9 amps. Here we have everything in series, 1, 2, 3, 4 light bulbs, all hooked up one after the other, one circuit, one loop, and 1, 2, 3, 4 batteries, again in series. And then we turn this power on, and look, the 4 light bulbs are just as bright as the first light bulb, and we are still drawing 3.9 amps. So, what have we learned from this? Well, if theoretically we have a infinite amount of batteries hooked up in series, each battery running an infinite amount of power, infinity times infinity, which is a lot of voltage. If we also complete the circuit with an infinite amount of light bulbs rated to take infinite amount of power, the circuit will still be the same as one battery with one light bulb. And now the similar circuit to what every other HHO user is doing. We'll say that this light bulb represents all the power being drawn by your car, by your engine, whatever, and this light bulb represents an HHO unit being hooked up. As you can see, we have 3.6 amps because we've hooked these up parallel. They draw more amps. Now if you hook a light bulb up in series, it uses less amps. More amps, less amps. 3.6.9. Alright, now here we have a circuit very similar to the one that I already drew. We have a battery, let's see here. These batteries are set at 6 volts apiece. Being stacked, they are at 12 volts. Here we have an amp meter. Here we have one light bulb in series, and this is what I was proposing, that these three lights represent HHO units. Now then, we take the one switch and we have light here, we have light. Well, this is representing an HHO unit. You'll see that we have light coming out of the bulb, and we are drawing 1.2 amps. We will now turn on the second light. Now watch what happens as I turn on the second circuit. The light bulb here, representing my motorcycle headlight, gets brighter, and there is power running through the two bulbs, but they've gone dimmer, which is what I want also, because I want to divide the heat between the hydrogen units. Now we will hook up a third switch to the third hydrogen unit, and we will and the bulb gets brighter still, and now we are drawing 1.54 amps. We turn it off, and the amps goes down. We hook it back up, the amps goes up. We turn it off, the bulb gets dimmer. Turn another one off, the bulb gets dimmer. Hook it up, the bulb gets brighter. Hook it up, the bulb gets brighter. This is why we're hooking up multiple HHO units, to get to as close as zero resistance as possible in this circuit. We're not trying to get zero resistance here, we're trying to get zero resistance here.